We're going to discuss the relationship between modern rivers and ancient sedimentary deposits. Conventional geologic theory proposes that many of the geologic formations were formed and shaped by the action of rivers and other similar processes. So let's look at modern environments that deposit and erode sediment and see what they are like. In this picture you see several modern environments. At the left is what's called a braided stream. It carves a path through the landscape, depositing sediments and eroding as well. On the right, you see a little different kind of stream, a more rapidly flowing stream or river that shapes the landscape. The lower left is more of a marsh. It doesn't have such vigorous action. And then the lower right is an ocean, and you can't really see what's happening, but down there under the water, sediment is being deposited and sediment is being eroded. In the middle, there's a diagram that illustrates what you find if you dig into the sediment where a river has been eroding. You find all kinds of complex deposits in there. So you should be able to identify when a river has been shaping the landscape. There are many ancient rock formations that cover vast areas. This is very different from what we see happening today. For example, look at the picture on the right of the Mississippi River floodplain taken from a satellite. You can see the Mississippi River flowing diagonally across the picture, and you notice off to the right and also off to the left, the landscape looks different than it does through the middle. That's because the part in the middle, that belt through the middle, is the Mississippi River floodplain. That's the area where the river, through hundreds of years, and maybe even several thousand years, has been depositing sediment and eroding it in cycles, depositing it and eroding. And so rivers leave their evidence in a belt like that. They don't wander randomly all over thousands of square miles. So now look back again at that map on the left. The Morrison Formation goes almost from Canada to Texas, several 100,000 square miles. How do you do that? Rivers don't cover a huge area like that. Compare that with the Mississippi River on the map. It's very small, very narrow compared to that Morrison Formation. What we see in the rocks does not match what seems to be happening today when water is eroding and forming sediment. Rock formations often cover 100,000 square miles or even much more. Here we see three pictures that illustrate some of these rock formations. Look at the middle one. You see a reddish layer at the bottom, then a whitish layer, and then other layers above it. Those layers are very continuous, and they go much farther than what you see in this picture. In fact, look at the lower picture. That's that white layer in the middle of the other picture. That's called a Navajo sandstone. And that is a flat, even layer of sand that goes 500 miles north and south, 300 miles east and west. Enormous deposit. How do you do that with rivers or any similar process? So we compare again the rock formations and the river. The two upper pictures are rock formations. The lower one is the river that supposedly was active in forming at least part of those rock formations. And yet it just doesn't match. The river covers a small area. The river is constrained between the hills and mountains on each side, and it only is active in that area. It does not cover thousands of square miles like these rock formations. And there are other processes besides rivers that also are active in forming these rock formations, but they also do not cover these enormous areas like we see in the rocks. If rock formations had accumulated over very long time periods and had experienced the normal erosion that we see happening on the earth today, they should look very different than they do. For instance, look at the diagram at the right. At the top, in A, you see several layers of sediment deposited flat and even. Now, what happens today is that you deposit those layers and they get eroded like you see in B. They get eroded into irregular landscape. Now, if you deposit some more layers on top of those, like C, they will fill those gullies and those valleys. And then if erosion happens again on top of those, it will look like D, very irregular. That's the way the ancient rocks should look if they had been formed over very long time periods. But they don't. They look more like what's at the bottom in E. Look at those pictures at the left. Don't they look more like E than like D? There is a mismatch between what we see in the ancient rocks and the theory of how they formed and what we actually see in the rocks. In this diagram, you see at the top, again, some more pictures of these rock formations. At the bottom, you see a diagram which represents what you would see if you could cut a cross-section down into those rocks. If you could take a giant bulldozer and just cut a big trench down through the rocks and see what they look like in cross-section. This diagram represents what's actually found in the Rocky Mountain area about 200 miles wide. And all these rock layers are very uniform. There are some places where one rock formation ends and another one starts, but they are very extensive and even. That's typical of the Paleozoic and Mesozoic sedimentary deposits. Now let's add some more to that diagram. The bottom is what you would see if you cut your trench at the end of the Mesozoic. You would see all of these layers that cover just enormous areas. Now, at the end of the Mesozoic, something happens. The Rocky Mountains form, and like you see in B, they uplift these rocks and fold them to make the landscape that you see in B. The lower Cenozoic sedimentary deposits now have to fill only the basins that are left, and so they're smaller, but they're still pretty big. But since those formed, erosion has continued to shape the landscape into what we see at the top, in letter C. And so you can see the old Paleozoic and Mesozoic formations that have been folded up, but then you see above that more recent things. And look right at the middle, there's a river. That's where things are happening now, on a very small scale. Erosion and sedimentation is happening in local places like that today. And I had to make that river very exaggerated for you to even see it. And so again, we see a mismatch between geologic processes happening on the Earth now and what we see in the ancient rocks. Modern processes just don't produce those very widespread formations going hundreds of miles. Rivers and other modern processes just do not produce these very widespread deposits covering hundreds of miles like we see in the lower part of the geologic column. There is a great difference between those layers and what happens today. And those widespread older layers are much easier to explain in a major catastrophe like the global flood.